Hey guys, we're going to continue with our inventory type problems. Example 2. Go ahead and read through the second example on Canvas, or pause the video now and read through it, and then open up the accompanying spreadsheet to solve the problem. Okay, so similar concepts to the first example. This one just has some more things going on. We're minimizing cost and we want to meet our customers' demands. Those two components are the same. I have control over the number of units that I produce, but in this problem there's two ways to produce units: regular time and overtime. So I can decide how many regular time units to produce in quarter 1, 2, and 3, and how many overtime units to produce in quarters 1, 2, and 3. So two sets of decision variables. Let's go ahead and start with our constraints. One of the simpler ones is we can only make 2,700 of units with regular time. So this cell here must be less than or equal to 2,700. And that's true for each quarter. So I'm going to copy that across. This 2,700 was just data that I got from the problem. So now I've formatted it that way. In these inventory problems, we always want to calculate units available to meet demand. And this cell must be greater than or equal to our customer demand. That's the whole logic behind these inventory problems. Not everything we produce is available to meet demand. Some of it is unsuitable, as the problem says. So first I'm going to make a cell that calculates the actual number of units that I've produced that are suitable to meet demand, suitable unit production. Everything I produce, whether it's in regular time or overtime, 20% of that goes bad. So therefore, 80% of it is suitable. So I'm going to multiply this times 1 minus my spoilage, or unsuitable percentage, in B7. So I'm just going to use made up numbers to help with the formula, or to make sure they're working correctly. If I produce 50 and 50, 20% of those go bad, so 80% would be usable or suitable for demand. Now my units available to meet demand is what is suitable from production plus what I have on hand, or my beginning inventory. And this units available to meet demand must be greater than or equal to customer demand. Customer demand is given in the problem for quarter 1 is 3,000, 2,000, 4,000. I'm going to use my format painter to copy the format onto those cells. Each quarter must be greater than or equal to those numbers. Not finished yet though, let's now calculate my ending inventory. This problem also has a different kind of twist to it, where not all of our ending inventory is usable for the next quarter. So I'm going to have a cell that has usable ending inventory. So first, let me calculate just my regular ending inventory, which is just everything that's available to meet demand minus what the customers have purchased. Okay, that's what we used in the last problem for ending inventory. But the problem says that some of this spoils, or it goes bad, or it's unusable for the next quarter. 10% of it spoils. So therefore 90% of it is usable, or 1 minus the spoilage percentage in D7. Now let's move on to quarter 2. The formulas are going to be pretty similar. My suitable production, again, is everything that I produce in regular time and overtime, but then I'm going to multiply it by 1 minus the 20%. I want to drag this over to save some time for each quarter. The only thing, let's double check, there's a cell that I don't want to slide over. I want the cell on the 20%, this B7, to stay locked into place. So before I slide it over to quarter 2, quarter 3, let's go back to this formula and lock my B7 cell. That's going to ensure that when I slide it over, the 20% stays locked into place, while the blue and the red boxes slide over to quarter 2 and 3. Perfect. units available to meet demand in quarter 2 is everything that's suitable of production to meet demand, plus my beginning inventory. My beginning inventory for quarter 2 is the usable ending inventory for quarter 1. Drag that across for quarter 3 also. Same thing here, I want to drag this across to quarter 2 and 3, but I'm going to lock my spoilage percentage to make sure that when I slide across to quarter 2 and 3, these things move over, these two cells, but this one stays locked into place. Now let's compute some costs. Our objective again is to minimize cost. So I'm going to have a total cost cell. That's my objective, so it'll have a double outline border. This one has several cost components to it. I have regular time cost, overtime cost, and then holding cost. So everything that I produce on regular time, a sum product of regular time units produced times their regular time cost per unit. Overtime is a similar formula, sum product of everything I produce on overtime times the overtime labor cost per unit. And then the holding cost, everything that is suitable in ending inventory, I must pay to store. End of quarter holding cost per unit. My total cost is a sum of all three cost components. Now let's solve it. Here we have two sets of decision variables, so how to input two different sets. I highlight the first one, put a comma, and then highlight the second one. Okay, we have a solution and a production plan. These numbers here, if you get these, that's just a formatting thing. It's in scientific notation, so if I'd rather see it in regular numbers, highlight those and change it to number. That just means 0. Okay. We see each breakdown of the cost component, and then for total cost, total minimum cost, $445,360.